very good evening, dear students. To myself, Dr. Rajashree, Dhua, Assistant Professor, EEE Department. Today, I am going to discuss a topic on the subject of electrical and hybrid vehicle with the subject code P602A. That is a subject for the sixth semester students of EEE Department. We have already discussed about series hybrid drivetrain and parallel hybrid drivetrain with torque coupling. Next, we are going to discuss about the electric vehicle drivetrain. Now, this is a particular schematic of a electric power train. As we can see, there are several modules. So let us now discuss about the modules. So as we can see, these are the drive wheels and this dotted lines are the signals. Then we have the transmission of electric power via these lines and the double lines show the mechanical power. So, a electric powertrain system functions to provide the required propulsion power in accordance with the commands of the driver by interfacing the batteries with the vehicle wheels at a very high efficiency. And the electric powertrain, as we can see, consists of mechanical transmission and several electric modules. The electrical modules consist of subsystems like the traction motor or the electric motor, the power electronics that is composed of the charge controllers, inverters, and converters, and the power sources of the storage, which can be batteries, capacitors, and flywheels. Apart from that, there are auxiliary devices, the electronic controllers, and the power management system. Now, the mechanical module, as we have shown, it consists of the transmission system, which can be optional, the differential system that can be optional, and the drive wheels. The electronic module consists of three functional modules consisting of sensors, interface circuitry, and microprocessors that optimizes and monitors the powertrain performance. The sensors, what do they do? They acquire the measurable quantities such as temperature, speed, torque, current, voltage, and convert these quantities into suitable electronic signals. And the interface circuitry conditions these signals to the appropriate level before sending them to the microprocessor. And the control unit, which has been referred to as the power management control system. It controls the application of the traction motor and optimizes the power flow between the different powertrain components so that we can maximize the driving range. The powertrain of the battery electric vehicle, as we can see, is much more simpler than a IC engine vehicle or a hybrid electric vehicle. The power is transmitted to the drive wheels through a few select components. Another key advantage of the electric powertrains over their IC counterparts is that they can recuperate the kinetic energy wasted during braking by the process of regenerative braking, as well as they can potential to generate and store the energy while traveling downhill. In this situation, as we have already discussed, the motor operates as a generator to produce the electric power. In addition, the rapid dynamics of the electric motors in the battery electric vehicles enable accurate control of the wheel torque, thereby achieving better handling performance. Moreover, this advantage also allows stability and safety control systems such as active cruise control, collision avoidance, and vehicle stability control so that the vehicle can perform faster and it results in better vehicle safety. So, this is how the components are discussed in a electric powertrain. Now we also have to learn about the different configurations of the electric powertrain. Now, the next topic of discussion is the types of electric powertrain. There are two types of electric powertrain system. One is converted and the other is dedicated. In converted system, what happens is that an electric motor and the batteries, they replace the IC engine and the fuel tank part, while the rest of the powertrain components, including the transmission and the differential, they remain the same. So this particular figure 12 is a schematic of a converted rear wheel drive electric powertrain where D represents differential. Differential allows the wheels, drive wheels to turn at different speeds. While figure 13 shows the schematic of a converted front wheel drive electric drivetrain. Now what happens is that, so we have already discussed that figure 12 and 13 respectively depict the converted rear wheel drive and the front wheel drive electric powertrain system. In such systems, the electric motors and the batteries, they are mounted on the vehicle chassis and the power transfers to the wheels to the transmission system. A clutch or a torque converter can be there depending on the use of a manual gear or automatic transmission gear, and they can connect or disconnect the power flow from the electric motor to the drive wheels. So what we have a transmission system, we have a battery, and we have an electric motor. So this is the converted rear wheel one. And in the front wheel via the transaxle, the batteries and the electric motor which generate the necessary torque to drive the wheels. Much like conventional powertrains, the transmission system adjusts the electric motor torque outputs. Now, what we can say that the proper arrangement and the configuration of electric powertrain system depends on several factors like performance expectations, the vehicle constraints, and the types of energy sources. Some other dedicated electric powertrain configurations for the propulsion system of a BEV are as follows. So, let us first see the figures and the types. So, this particular figure 13 shows a out wheel motor rear wheel drive on an electric powertrain configuration. So this is the differential, this is the fixed gear, this is the electric motor. Figure 14 basically shows the configuration of a out wheel motor front wheel drive on an electric powertrain. So the electric motor, the fixed gear and the differential, they are all mounted on the front wheels. Now we have figure 15, that is a dual out wheel motor front wheel drive powertrain configuration where we have different electric motors and fixed gears for the two wheels in the front, two different wheels in the front. And figure 16 shows a in-wheel motor all-wheel drive on an electric powertrain configuration. So let us now discuss about this. So the out-wheel motor rear-wheel drive. This particular configuration consists of an electric motor, a fixed gearing and a differential. Typically, the fixed gearing is a planetary gear set with a fixed forward gear ratio along with one reverse. Unlike the conventional IC engines, the modern EVs can easily achieve the desired top speed characteristics for vehicle motion through a combination of electric motor and fixed gearing. In IC vehicles, we need multiple gears that we have already shown because in order to get the ideal tractive effort versus speed characteristics. Generally, the electric motor has constant power at a greater speed range. In comparison to the converted electric powertrain, this configuration is much simpler. It is light in weight and small in size due to the removal of the complex transmission system and the clutch and the torque converter. So this is the powertrain configuration. Now coming to the out-wheel motor front wheel drive. The principle of this configuration is quite analogous to the front engine front wheel drive of a conventional vehicle in which all the powertrain components they compact and integrate on the front axle. This configuration also consists of an electric motor, fixed gearing and a differential, all of which are integrated into a single assembly. As we can see that all of this is integrated in a single assembly on the front wheel. Now, dual out wheel motors, front wheel drive. Most of the configurations that we have mentioned, the motion of the left and the right wheels are separated from each other by a mechanical differential. In contrast, this particular dual out wheel motor front wheel drive, what it does is that separate electric motors and fixed gearings are needed for the to drive the separate wheels. This configuration provides better vehicle stability since electric motors can accurately control the individual wheels. However, the use of the additional electric motor, the additional power converter and the fixed gearing increases the initial cost of the system. Now coming to the last configuration, that is the in-wheel motor drive. In the in-wheel motor drive technology, it can minimize or eliminate the need of the mechanical components of the electric powertrain system. In this particular design, the electric motors are placed inside a pair or all of the wheels with or without the fixed gearing. The fixed gearing, along with the high speed inner rotor electric motor, enables the desired wheel speed to be achieved by reducing the motor speed. On the other hand, it is also possible to install a low speed outer rotor electric motor inside a wheel without a fixed gearing by mounting the outer rotor onto the wheel rim. In this arrangement, what happens is that the electric motor is the sole controller of the torque and the wheel speeds. So the electric motor directly controls the wheel torque and that is the vehicle speed. The arrangement is already shown. It represents the in-wheel motor all-wheel drive arrangement in which achieving the benefits of the front wheel drive, rear wheel drive and all-wheel drive configuration happen easily by turning the related electric motors on and off. Despite having certain advantages, the implementation of an in-wheel motor likely will induce a heavier combined tire wheel suspension system, and this characteristics is quite undesirable in relation to vehicle dynamics and stability because when separate motors are used for all the wheels, so the weight increases naturally. Furthermore, the electric motors also need to have high resistance against excessive lateral and longitudinal roads and water intrusion. So wear and tear will be much there. So for that purpose, the motors should have high resistance against excessive lateral and longitudinal road loads. So these are the different configurations of the converted and the dedicated types of electric vehicle powertrain configurations.